Hi everybody, this is the video for magnetic fields lesson 4.1. I'm gonna start out by actually going over a couple slides from Amplify. So we are in the last chapter of our magnetic fields unit. So we've learned everything we need to know so far, and in this chapter we will be taking a look at electromagnet roller coaster designs and trying to figure out which one is going to be the best design and then writing an argument for it. So this is a letter from some students that made roller coaster designs, and they said, we are designing electromagnet roller coasters for a physics competition at our school. We heard about your work with the spacecraft mystery and would like your help. We have developed 3 different designs and gathered some initial evidence, but we can't decide which design will be fastest. Please use what you have learned from investigating the spacecraft to evaluate our designs and to send us an explanation about which design to build for the contest. Thank you. So first thing I want to do is just quick over electromagnets. In the previous lesson, you should have watched the video for electromagnets and know what they are, but basically they can be made from a simple battery and a coiled wire. So you connect the wire to one side of a battery, coil it around a nail, and then connect it to the other side. Once it's connected, this will turn into a magnet, and that's we call it an electromagnet because we need electricity to get it started. Powerful electromagnets are used to launch the fastest roller coasters. So if you've ever been to Disney or Universal or somewhere with roller coasters and you've been on a roller coaster before, those are usually powered by electromagnets. So we're going to take a look at 3 designs and try to figure out which one is the fastest. So here I have linked for you the different designs for you to go through and really look at. And what I want you to really do is possibly something like this. And you don't necessarily have to, actually write on them, but think about things like this. Could this affect the magnetic force and potential energy in the system, right? We've talked about closeness of magnets, of repelling magnets, and how much energy that will be in the system. And does the number of coils affect magnetic force? Also, things that you want to think about is the setup of the magnets and these guide rails along the edge. So maybe pause the video now and go click this and look through these designs, thinking about what you've learned while investigating the spacecraft, and then put here which one you think is the fastest before you do any research. Next thing you're going to do is take a look at some evidence cards, and all the evidence cards are experiments. So when we look at experiments, we want to see if these experiments are valid, and how we can do that is seeing if the test variable is isolated. So what do I mean by that? I only want to change one thing in between all tests. So when I look here on evidence card E, what is the effect of the arrangement of magnetic poles? So what I'm testing is the arrangement of the poles. I'm not testing the amount of magnets. I'm not testing distance. I'm not testing materials. I'm only testing the arrangement. So when I look at this, I can see, okay, here I have, opposite poles next to each other. Then I have 2 here, and all poles facing the same side here. What variables are being tested? Okay, I'm definitely testing the arrangement, but also what else is being tested here? And this one I have 2 magnets, this one I have 4, and this one I have 2. That is different between all tests when I'm just trying to isolate one variable, the arrangement. So this test I would not say is a very good, valid test, because there's different things. There's more than one thing's changed between tests. So think about these questions. What variable is being tested? How are effects measured? which test variables were changed and which stayed the same? And can you conclude that the difference in results is due to the effect of the test variables? I can't say for certain that is true here because it could be that, this one is just a higher reading because it has more magnets than this one. So you'll go through and do that for each card. So which variable is tested? You can get that most likely from the question up here. How were effects measured? So I'll do this one with you. The variable being tested here is, again, the pole arrangement. How are my effects measured? I can see here a sensor to measure magnetic force was placed 1 centimeter from each set of magnets. So I used a magnetic force sensor. You can see the readings down here, and they're all in the same units, so that's good. Which variables were changed and which stayed the same? So looking here, what changed? And it should be the same as your test variable. So what changed was my pole arrangement. And if I saw here that also the number of magnets were changed, I would put that here too. But luckily here, it looks like everything else is the same. So stayed the same number of magnets. Distance of sensor. Right, you can see that here, that a sensor was always placed 1 centimeter from each set. And there could be other things here that I'm missing right now, but basically the main thing is we want to just make sure only one thing's changed between tests. Can you conclude that the differences in results are due to the effect of the test variable? And here I'm going to say yes, because our test variable was isolated. Okay, and you'll do that for each evidence card. And then on the last slide, any of them that the variable wasn't isolated, that, like in this example where there's 2 different things changing, we're going to scrap those evidence cards for our next thing. So I would definitely say that evidence card A was good, but here we are looking for ones that we can eliminate. So card A is good to go, and we might need to eliminate 1, 2, 3, or none of the cards.